Hello everyone, in this video we will talk about the parabolic function. First of all, what is a parabolic function? A parabolic function is any function that is in the form of y equals ax squared plus bx plus c, such that a can be any number different than 0 and b and c can be any number. So for example, y equals x squared, y equals 3x squared plus 1, y equals 5x squared plus 9x, y equals 3x squared plus 6x plus 7. All those equations and much more are representing a parabolic function. So a should not be equal to 0 in a parabolic function. That means that x squared will always be presented. And in a parabolic function, x squared must be the highest exponent in the polynomial. What does that mean? This indicates that, for example, the function of y equals x to the power 3 plus x squared plus x plus 1 is not a parabolic function, because in this case we have x to the power 3 that is greater than x to the power 2 in exponents. This indicates that this function is not a parabolic function. X squared should be always represented and should be the highest term to make this function a parabolic function. Let's now discuss the graphical representation of a parabolic function. The graphical representation of a parabolic function is a U-shaped curve, whereas the location and the concavity and the direction of the curve is specified by the constants a, b, and c in the equation of y equals ax squared plus bx plus c, as we've said, where a is any number different than 0, b and c can be any number. Now, if a is greater than 0, then the parabolic function will be a concave up function or concave up curve having the shape of u, like this. While if a is less than 0 or negative, then the function or the curve will be concave down, having this shape. The constant c represent the y-intercept, which is the intersection between the y-axis and the parabola, like the constant b in a straight line function having y equals ax plus b. Let us now take another property. For the absolute value of a is increasing and for the absolute value of a is decreasing. For the absolute value of a increasing, this makes the parabola tighter. While if the absolute value of a is decreasing, this makes the parabola wider. Let's take y equals x squared plus 1. This is a parabolic function because it is in the form of y equals ax squared plus bx plus c, such that a is equal to 1, b equals to 0, and c equals to 1. And the function of y equals 3x squared. This is also a parabolic function having a equal to 3 and b equal to 0 and c equal to 0. In the first parabolic function we have a equal to 1, while in the second parabolic function we have a equals to 3. We can see from the property that the second parabolic function will be tighter than the first parabolic function. This makes that y equals 3x squared is tighter than y equals x squared plus 1. This also is applied on the negative a. So let's take the examples of y equal minus x squared and y equals minus 3x squared plus 1. Both are parabolic functions. So let's take for the first parabolic function, a is equal to minus 1. Then the absolute value of a is equal to 1. For the second parabolic function, a is equal to minus 3. Then the absolute value of a is equal to 3. Then also in this case, y equals to minus 3x squared plus 1 is tighter than y equals minus x squared, because the absolute value of a in y equals minus 3x squared plus 1 is greater than the absolute value of a in y equals minus x squared. In order to make the idea of the parabolic function clear, let's take some examples and try to draw them on the coordinate system. Let's take the first example of y equals x squared. This is the simplest parabolic function we will ever see. Then, in order to try to draw this parabolic function on the coordinate system, we will have to get some points on the graph of the parabolic function and try to join them in a U shape. So let's take the first point of x equal to 0, then y will be equal to 0, and this represents the origin of the coordinate system. For x equal to 1, y is equal to 1. For x equals to minus 1, y is also equal to 1. For x equal to minus and plus 2, y will be equal to 4, and much more. So let's plot now those points and join them in order to find the shape of this curve. Then the first point is on the origin 0, 0. The second point has the abscissa of 1 and the ordinate of 1. Then the point will be here. The third point will have the abscissa of minus 1 and the ordinate of 1. Then the point will be plotted here. And the third and the fourth and the fifth point have minus 2, 4 and 2, 4. Then the points will be located on the abscissa of 2 and the ordinate of 4, and the point will be plotted here, and the final point is on abscissa minus 2 and ordinate of 4, then the point will be located here. Thus, if we try to join the curve by a U shape, we will have this form. If we try, let's now take the graph of y equals to minus x squared plus 1. In order to draw this graph, we have also to find some points on the curve and try to join them in order to find the U shape of this graph. So let's take for x equal to 0, y will be equal to 1. For x being minus or plus 1, y will be equal to minus 1 plus 1 equal to 0. For x equal to minus or plus 2, y will be equal to minus 4 plus 1 equal to minus 3. These are the coordinates of the points on the graph: 0, 1, minus 1, 0, and 1, 0, and finally minus 2, minus 3, 2, minus 3. Let us plot those points on the coordinate system in order to find the shape of the U curve. So the first point is minus 1, 0, so minus 1, 0. The second point is 0, 1, 0, 1. The third point is 1, 0. And the fourth and the fifth point is minus 2, minus 3, and 2, minus 3. Then the U shape will be upside down, having the concave down shape, because as we've said, A is negative, so the shape will be concave down. Let us now take the example of y equals to minus x squared plus x plus 1. So let's take for x equal to 0, y will be equal to 1. For x equals to 1, then y will be equal to minus 1 plus 1 equals to 1. And for x equals to minus 1, then y will be equal to minus 1 plus 1 equals to minus 1. For x equals to minus 2, y will be equal to minus 4 minus 2 plus 1 equals to minus 5. And for x equal to 2, y is equal to minus 4 plus 2 plus 1 equals to minus 1. Then we should plot those points of the coordinates 0, 1, 1, 1, minus 1, minus 1, and minus 2, minus 5, and 2, minus 1 on the coordinate system in order to find the graph of this parabolic function. The first point is on abscissa 0 and ordinate 1, so it is this point. The second point is for the abscissa 1 and coordinate 1, and ordinate 1, sorry. And the third point is on minus 1, minus 1. The fourth point is on minus 2, minus 5. And the final point is on 2, minus 1. So if we join those points with an approximate vertex, we will have this parabolic shape. We can notice that in all cases, we have the parabolic curve that is symmetry with respect to the axis passing through the vertex of the curve.